Today, we're going to learn how to make long term predictions based on theoretical probability. When we do this, we use what is called relative frequency. Relative frequency is the probability of an event, usually expressed as a fraction or a decimal. So basically, when we say that we're using relative frequency, that means that we are using the probability of an event. So, to use relative frequency to make long term predictions of an event, all you have to do is multiply the probability, either as a fraction or a decimal, because remember, we can never multiply with percents, by the number of trials. So, what does that mean? Let's look at some examples. You have this spinner, and it says if you spin the spinner 400 times, how many times can you expect to land on a 4? Well, the first thing that you would want to do is to find the probability of landing on a 4. For this spinner, we see that there is 1 4 out of 8 total spaces. So the probability of landing on a 4 is 1/8. This is the relative frequency of landing on a 4. To make a prediction based on this, I know that we are spinning the spinner 400 times. So I am going to multiply 1/8 times 400. Well, if I multiply 1/8 times 400, I'm going to get, well, I can put 400 over 1, and then I would multiply 1 times 400, which is 400, and 8 times 1, which is 8. When I divide, because that's what my fraction bar means, 400 divided by 8, I get 50. So this means if I roll 400 times, I expect to land on a 4 50 times. Number 2 asks, if you spin the spinner 400 times, how many times can you expect to land on a yellow? Well, when I look at my spinner, I see that there are 2 spaces that are yellow. So the probability of landing on a yellow is 2 out of 8 total spaces. Well, 2/8 can be simplified. I know both of these are even numbers, so they can be divided by 2. 2 divided by 2 is 1, and 8 divided by 2 is 4. So the probability of landing on a yellow is 1/4. To figure out how many times I would land on a yellow, I'm going to take this relative frequency, which is 1/4, and multiply by the number of trials, which is 400. So I'll do 1/4 times 400. Since 400 is a whole number, I can put it over 1 and I can multiply. 1 times 400 is 400, and 4 times 1 is 4. Then I would simplify this, or in this case, just divide. 400 divided by 4 is 100. So this means that if I spun the spinner 400 times, I would expect to land on yellow 100 times. Number 3 asks, if you spin the spinner 400 times, how many times can you expect to land on a 3 or a 6? When I look at my spinner, I see that there is 1 3 and there is 1 6. So that means that there are 2 total spaces on the spinner that would be favorable outcomes. So the probability of landing on a 3 or a 6 is 2 out of 8. Well, 2 out of 8 can be simplified to 1/4. If I'm going to spin my spinner 400 times, I'm going to take this relative frequency of 1/4 and multiply it by 400. Well, we just did that, and we know that when we multiply 1/4 times 400, we get 100. So if we spin the spinner 400 times, we would expect to land on a 3 or a 6 100 times. Number 4 says, if you roll the number cube 120 times, how many times can you expect to land on an even number? So the first thing we need to figure out is the probability of landing on an even number. I know that there are 3 even numbers on a number cube. Those are 2, 4, and 6, out of 6 total numbers. Well, I need to simplify 1 or 3/6, and I know that 3/6 can be simplified to 1/2. To figure out how many times I would land on those, I'm going to take my number of trials, which is 120, and multiply by my relative frequency, which is 1/2. So 1/2 times 120. Again, I can put my whole number over 1 and multiply. 1 times 120 is 120, and 2 times 1 is 2. So then I would solve 120 divided by 2, and that is going to give me 60. So I would expect to land on an even number 60 times if I rolled the number cube 120 times. Number 5 says if you roll the number cube 300 times, how many times can you expect to land on a number greater than 2? First thing I need to know is what is the probability of landing on a number greater than 2? Well, on a number cube, the numbers that are greater than 2 are 3, 4, 5, and 6. So there are 4 numbers that are greater than 2 out of 6 total numbers. Well, if I simplify 4/6, I know I can divide both of these by 2, so my simplified fraction would be 2/3. Now, because I'm going to do this 300 times, I want to take my relative frequency of 2/3 and multiply by my number of trials, which is 300. I can put a 1 under my 300 and I can multiply. 2 times 300 is 600, and 3 times 1 is 3. If I divide 600 by 3, I'm going to get 200. So I would expect to land on a number greater than 2 200 times if I rolled a number cube 300 times. Number 6 says if you roll the number cube 300 times, how many times can you expect to land on a number less than 6? I want you to solve this problem and put your answer in the chat. To find this, I would first start with the probability of landing on a number less than 6. Remember, that does not include 6. So there are 5 numbers less than 6 out of 6 total numbers. Then, since I'm rolling 300 times, I'm going to multiply 5/6 times 300. And I can put 300 over 1. 5 times 300 is 1500. And 6 times 1 is 6. Now all I have to do is divide 1500 by 6, which is going to give me 250. So if I roll the number cube 300 times, I would expect to land on a number less than 6, 250 of those times. Number 7 asks us to roll the number cube 3,000 times, and we want to know how many times we can expect to land on a 5 or 6. So solve that and put your answer in the chat. The first thing I would need to do is find the probability of 5 or 6. Well, I know there's 1 5 on a number cube and 1 6. So in total, there are 2 favorable outcomes out of 6 total. If I simplify 2/6, I'm going to get 1/3. I know that I'm going to do this 3,000 times, so I'm going to multiply my probability, which is 1/3, times my trials, which is 3,000. I can put 3,000 over 1, and then I can multiply. 1 times 3,000 is 3,000, and 3 times 1 is 3. If I divide 3,000 by 3, I'm going to get 1,000. This means I would expect to land on a 5 or a 6 1,000 times if I roll 3,000 times. Now for number 8, let's look at this spinner. What is the first thing you notice about this spinner? What we should see is that this spinner is not split into equal pieces. It's actually split into 5 pieces, but they are not equal. But if we notice, A, B, and E do look equal. So if we look at this, C and D, if they were one piece, would probably be equal to A, B, and E. So that means A is 1/4 of our spinner, B is 1/4 of our spinner, and E is also 1/4 of our spinner. But C and D together are 1/4. So that means each one of these is actually 1/8 because it's 1/4 divided by 2. Now, if we spin the spinner 400 times, how many times could we expect it to land on a vowel? Well, when we look at our spinner, A is a vowel and E is a vowel. So there are 2 vowels on our spinner out of 4 pieces. So the probability of landing on a vowel would be 2 out of 4 or 1/2. If I'm spinning my spinner 400 times, I'm going to take 1/2 and multiply by 400. Well, I would put 400 over 1. 1 times 400 is 400, and 2 times 1 is 2. So now I'm going to divide 400 by 2, which would give me 200. So if I spin the spinner 400 times, I would expect to land on a vowel 200 of those times. Number 9 asks, if you spin the spinner 500 times, how many times can you expect it to land on a consonant? Well, when I look at my consonants, those are B, C, and D. Well, when I look at this, those take up half of my spinner. So the probability of landing on a consonant is 1/2 on my spinner. If I'm spinning this 500 times, then I'm going to multiply 1/2 times 500, or 500 over 1, which will give me 500 divided by 2. And 500 divided by 2 is 250. So I would expect it to land on a consonant 250 times if I spun it 500 times. Number 10 asks, if you spin the same spinner 500 times, how many times can you expect it to land on a C? I want everybody to find that answer now and type it in the chat. For this, the probability of a C is 1/8, which we know because if we split all of the rest of these into half, then there would be 8 equal pieces, and C is one of those. So there is 1 C out of 8 pieces. To find the frequency or the long-term prediction of this, I'm going to take 500 and multiply by 1/8. Well, when I do this, I'm going to get 500 over 8, or 500 divided by 8. Well, that gives me an answer of 62.5. But it's not possible for me to spin a spinner 62.5 times. So if I get an answer like this, I'm going to need to round this. So I would say approximately 63 times. Number 11 says, if you spin the spinner 500 times, how many times can you expect it to land on a B? I want everybody to solve that now and type your answer in the chat. For the probability of a B, we would first find the probability of B on our spinner. Well, there are 4 pieces and one of those is B, so the probability of a B is 1/4. And if I'm spinning 500 times, then I'm going to take 500 and multiply by 1/4, which is going to give me 500 over 4. And when I divide that or simplify that, I'm going to get 125. So I would expect it to land on a B 125 times out of 500. Number 12 says Bethany's boutique received a shipment of new clothes. When she opened the first box, she found that 15 out of 50 of the clothing items were graphic t shirts. If this sample is representative of the 450 items that she ordered, how many of them will probably be graphic t shirts? Well, I want to know how many will be graphic t shirts, so I'm going to use the probability that I know from the problem. The probability of a graphic t-shirt is that in the box there were 15 graphic t-shirts out of 50 items. So that is 15 over 50. Now I should simplify this, and I know that both of these can be divided by 5. When I do 15 divided by 5, I get 3, and when I do 50 divided by 5, I get 10. So the probability of a graphic t-shirt is 3/10. Now I know that she has 450 items, so I'm going to take 3/10 and multiply by 450. Well, I'm going to put 450 over 1, and then I'm going to multiply. So 3 times 450 is 1,350, and 10 times 1 is 10. Well, if I divide 1,350 by 10, I'm going to get 135. So in this shipment, I would expect 135 graphic t-shirts. The last problem on your notes says Stephanie received telemarketing calls on 12 days in August. Express the relative frequency of Stephanie receiving a telemarketing call as a fraction, decimal, and percent. Well, the relative frequency, if you remember, is just the probability. So for this, it's not asking us to make a prediction, and instead, it's just asking us to show the relative frequency. So we're showing the probability. So the probability is the probability of receiving a telemarketing call. Well, I know that she received a call 12 days in August. But to figure out what the bottom number is, I need to know how many days there are in August. August has 31 days. So the probability of Stephanie receiving a telemarketing call is 12 out of 31. This cannot be simplified because 31 is a prime number. So there is no factor that it has in common. So we're going to do 12 over 31, and we're going to make this as a fraction. So we've already done that. A decimal. So to get from 12/31 to a decimal, we know that we need to divide 12 by 31. Well, when you do this, you're going to get a very long answer. So it's like 0.3870967. If we take this and make it into a percent, we know that we need to take our decimal and move it 2 places to the right, which is the same as multiplying by 100. So as a percent, this would be 38.709677%.